This video is going to build off of the previous one, looking at work, and is going to look at mechanical power. So if we remember that work is defined as work being equal to the force being applied to an object to move that actual object a set distance. And we're also going to come into play here the angle between these two objects. Okay, so the previous video looked at different types of work. We're now going to take this concept of work and we're going to apply it to mechanical power. So the formula for mechanical power has power being equal to the work that is done, or the amount of work that is done, over a set amount of actual time. Okay, so I'll rewrite that. Set amount of time. Now you might remember this actual formula from secondary 4 in the electricity unit. Because if we look at the electricity unit, where we had PE being equal to the work done over time, we had also said that work was the amount of energy consumed. So we actually changed up this formula to be PE equals the amount of energy over time. And we use this formula, okay, to actually give us things like energy cost calculations and watts and kilowatts. So this is what you know already with electricity. So we're going to actually use the concept of this formula and we're going to bring it back to mechanical power in physics. Okay, so if we've got mechanical power, it's known as the quantity of work done per unit of time. So looking at mechanical power, if we want to break this down from a physics point of view, we see that the actual power needed to operate something, okay, needed to get some work done, involves looking at the relationship between work and time. So it kind of makes sense that 1 watt, okay, is going to also be equal to 1 joule per second. Okay, because of the actual working of this formula. So let's look at an example. So we're going to look at calculating power solely, and then we're actually going to finish this little video off with looking at some kind of problem that you might expect. So oftentimes power problems will also have you solve for the work being done. Okay, so not only do you have to solve for the work and include it into the power, but you then have to solve for the power. So here we're looking at a power generated by a shovel that does 60 kilojoules of work in 1.5 seconds. So the key here is identifying the kilojoules. Okay, that's the one small trick in this formula or in this question, because the formula itself deals with joules, not kilojoules. So we are going to have to actually basically change or convert kilojoules to joules. So to show your work for that, because you know you have to show your work, we end up with 60 kg. And if I want to actually bring that down to joules, I know that in 1 kg, there are 1,000 joules. So this cancels out my kilojoules, and I'm left with 60 times 10 to the 3, or basically 60,000 joules. So once I have all of my variables, I can then input them into the formula and get my answer. So what we do is we input basically our 60,000 joules divided by 1.5 seconds, which gives us 40,000 joules per second. You could leave that as so, or you could change it to 40,000 watts or 40 kilowatts. The choice is yours. All are accepted. The next problem we're going to look at is a much more all-encompassing problem. And it has exactly, it talks about, or it looks at exactly what we talked about previously, in that you're going to be asked to solve for the work, then input that into a calculation for power. When we look at this actual problem, there's a lot of information being given to us here. All right, so it's important to write out what your givens are. So a few things jump out at me here in that we're given a lot of the information that we're going to need. But you notice down at the bottom of my list of givens, I have the two unknowns that I have to actually solve for. And if I look at my variables, I'm going to notice that one of them is not in the actual unit that I need it to be, so I'm going to have to show that conversion. So I'm going to actually convert my minutes to seconds, and once I have that, it's just a matter of plugging stuff in. So once I've converted my time, I'm now going to plug in the actual work formula because I have to solve my work first. So A, it's going to be work is equal to F times delta S times the cos of our theta. I have every one of these values, so I'm just going to input them in now. So this ends up giving me a work number of 137,454.41 joules of work. Now that I have that, I can actually look at my power because my power deals with work and it also deals with time. So part B of this is asking me to solve for power. Okay, and I know that power is going to be equal to the work done by the amount, or divided by the amount of time. I have my work value from above, okay, and I'm going to divide that by my 300 seconds. So that gives me a power rating or a power amount of 458.18 watts. So if we look at that, I mean, we can round that down to, 458, but this is probably the most complicated. One step further might be to actually get you to potentially solve for the actual force. Okay, but other than that, this is how we do power problems. So the only additional factor here might have to be to solve for force, and we know how to solve for F net. We know that it's a sum of all the forces that are at play to move that object. You might also be asked to create a free body diagram of the situation, but by now you know how to do those. Okay, so there's basically your first chapter on work and mechanical power.